Hello and welcome back to Math with Mrs. Becker. Today in College Algebra, we are going to go ahead and finish Chapter 2, Section 3, where we get to use the rational root theorem to break apart polynomials so we can find their zeros. Okay, back in Algebra 2, we did work with the rational root theorem quite a bit in Chapter 6. I called it the PQ method. Okay, and remember this method helps us to identify all of the possible roots. So when we go ahead and do that first step, which remember we take P. P is the constant over Q. Q is the leading coefficient. Then we list out all of the factors of each value. Remember, a factor is a numerical value you can divide by perfectly, so you would not get a decimal. Okay, so we go ahead and list out all of those factors. Those are our possible roots. To find out which ones are our actual solutions, we use synthetic division in a synthetic substitution table. Now we know that we found a solution if we end up with a remainder of 0. Every time we pull out one solution, we break down the polynomial a little bit more. From there, we look at what we have remaining. See if we can factor it. Maybe we can use the quadratic formula. Hey, if those two things don't work, you can go ahead and do the rational root theorem again. And we go ahead and keep breaking down the polynomial until we have found all of the real zeros. Finally, we want to check our work, make sure that we have accuracy as well. So we will go on to Desmos.com, plug in our polynomial function, and see where it crosses or touches the x-axis. So without further ado, let's get this party started. P is your constant at the end. So P is a negative 40 over Q. Q is the leading coefficient. That's a 1. Now this is kind of nice, okay? If we're starting off with a 1 on the bottom, that means that our possible solutions are going to be all of the factors of negative 40. What can I divide negative 40 by and not get a decimal? Well, positive or negative 1. I can divide 40 by positive or negative 2. Not 3, but 4. And 5. 40 is not divisible by 6, not by 7. Hey, it is by 8. And remember back in Algebra 2, I taught you this little trick. Once you have two factors that are next to each other that multiply to the value that you started with, so in this case, it would be 40. If I take 5 times 8, I get 40. Every other factor is going to have a partner. So the next factor is whatever you would multiply 4 with to get 40. So this is a 10. Your next one would partner with a 2. So that is 20. And last but not least, what would partner with a 1? 40. So here, this is what the rational root theorem does. It just allowed us to find all of our possible solutions. Now what we go ahead and do is we make a synthetic substitution table. So we want to go ahead and find our solutions. Across the top, this is synthetic division. So I go ahead and I'm going to use the coefficients. This is 4x's, 3x's, 2x's, 1x, no x's. So I will not have to add in any zeros. My coefficient for x to the power 4 is 1. Then my next coefficient is a negative 4. Negative 15, positive 58, and negative 40. Now what I need to do here is go ahead and try some of these values. I like to just go ahead and start off with a positive 1 and then go a negative 1, okay? Let's go ahead. This is synthetic division, guys. It's just in the table. So you carry down the first term. It's a 1. 1 times 1 is 1. 1 plus negative 4 is negative 3. Negative 3 times 1 is negative 3. Negative 3 plus negative 15 is negative 18. Negative 18 times 1 is negative 18. No way it's going to work. Negative 18 plus 58 is 40. 40 times 1 is 40. And positive 40 plus negative 40 is 0. So hey, you guys, we already found a root. That's awesome. Remember the last value, this is your remainder. If your remainder is 0, you found a 0. So one of my solutions is x equals 1. Now remember, we already talked about the fundamental theorem of algebra, and that's where you look at the degree of the polynomial, and that's how many solutions we're looking for here. I need to find 4 solutions because this polynomial function has a degree of 4. Right now I have 1. This is your remainder, this is your number, this is your x, this is x squared, this is x cubed. So I'm starting again. 1x cubed minus 3x squared minus 18x plus 40. Now from here, we need to continue and try to find 3 more zeros. If I look, I could go ahead and try the grouping method for factoring. If I grouped those 2 terms, what I could take out is x squared. So I would have x minus 3. Is there any way to make that x minus 3? Not so much. So guess what? We get to do P over Q again. However, we did kind of get lucky here. P, your constant, is 40. Over Q is 1. So I have 40 over 1. Well, negative 40 over 1 is going to result in the same possible solutions as positive 40 over 1. So we are still working with these possible solutions. Now, here, if you think about your multiplicities, we have to realize that we could end up with a 1 again. So even though 1 was already a solution, I don't want to give up on 1 yet. So I am going to go ahead and start with 1 again. Now across the top, it's my coefficients. 3x's, 2x's, 1x, no x's. So this is a 1. This is a negative 3. It's a negative 18 and a positive 40. Carry down that first value. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. Negative 2 plus negative 18 is negative 20. Negative 20 times 1 is negative 20. Negative 20 plus 40 is 20. Nope, didn't work. Okay, I'm going to go ahead and go to negative 1 now. So I know my positive 1, I do have that as a solution, but it's only a multiplicity of 1. So when we look at that graph, it should cross the x-axis as a straight line. Let's check with negative 1. So I'm going to carry down the 1. 1 times negative 1 is negative 1. Negative 1 plus negative 3 is negative 4. Negative 4 times negative 1 is positive 4. Positive 4 plus negative 18 is negative 14. Negative 14 times negative 1 is a positive 14. 14 plus 40, 54. Doesn't work. Okay, so we're done with those. Let's go ahead and try 2. Carry down the first term, which is a 1. I'm going to try to do different colors here just so it doesn't get all clustered. Carry down the 1. 1 times 2 is 2. 2 plus a negative 3 is negative 1. Negative 1 times 2 is a negative 2. Negative 2 plus negative 18 is negative 20. Negative 20 times 2 is a negative 40. Negative 40 plus 40 is 0. So, hey, we found another root. X equals 2 is a solution. Now, what I have remaining, this is a remainder. This is a number. This is x. This is x squared. So, as I continue, what I have remaining is x squared minus 1x minus 20, okay? The x squared is with a positive 1. The x is with a negative 1. My constant at the end is a negative 20. Now here, I have it at a point where I can for sure either factor it or do the quadratic because I have a quadratic trinomial. So I know that those are options. Let's go ahead and see if we can factor first because typically that goes a little bit quicker. Do we know 2 numbers that multiply to negative 20 and add to a negative 1? Well, heck yes, we do. We got x minus 5 and x plus 4. X minus 5 and x plus 4, that's factored because negative 5 times 4 would result in negative 20. Negative 5 plus 4 would give us our negative 1. Now, to find those zeros, you take each factor separately, turn it into an equation, set equal to 0. To solve for x here, I would add 5. So one solution is going to be x equals 5. Here, in order to solve for x, I would minus 4. 0 minus 4 would result in negative 4. So check this out. I needed 4 answers. I have 1, 2, 3, 4. All of them have a multiplicity of 1 because each 0 is unique. Now we want to go on to Desmos.com and go ahead and graph this and see what happens. So if I go into Desmos, which I know you're very familiar with, x to the power of 4 minus 4x to the power of 3 minus 15x squared plus 58x minus 40. So if I go ahead and check, I can see that on Desmos, there are 4 zeros. So what I can do is go ahead and tap on those zeros, and what we're doing is making sure that our x values match. We should have a 0 at x equals 1. There it is. How about a 2? Yep. 5. There it is, -4. And give yourselves a high five. You did it. All right. Guys, we got through the first question. We're like rock stars. Let's go ahead and try another one. Super fun, right? Okay, so starting off, if you have 4 terms, you will not always have to do the rational root theorem because we have learned other methods for finding zeros. So if I have 4 terms, before I go through all of that work, I do definitely want to make sure that I check and see if I can factor it. Well, in this case, I can't, because if I group those 2 terms together, I could remove 2 x's. What I'd have remaining is a 2x plus 1. I can't make that 2x plus 1, okay? So our only option now is to go ahead and do the rational root theorem. P is a 2. Q is also a 2. So what we have to do is list the factors of both, okay? The factors of 2 on the top, plus or minus 1, and plus or minus 2. The bottom, plus or minus 1 and plus or minus 2. So in order to get our possible answers, I have to take all of the values in the numerator over the first term in the denominator. Then all of the values in the numerator over the second term. Okay, so we are going to get some fractions, and that's totally fine. So 1 over 1 is 1. 2 over 1 is 2. So I'm done with the 1 on the bottom. Now I go ahead. 1 over 2 is 1/2. 2 over 2 is 1. We already have it listed. So here are our possible solutions. We need to find 3 solutions. Let's go ahead and make a table. So 3 x's, 2 x's, 1 x, no x's. So I have a 2, then I have a 1, then I have a -5, and I have a 2. Let's go ahead and try some of these values. I'm going to start off with the 1, just because it seems kind of friendly. Let's bring down, I'm going to use my different colors here, try to keep it organized. Bring down the 2. 2 times 1 is 2. Add them. 2 plus 1 is 3. 3 times 1 is 3. 3 plus a -5 is a -2. -2 times 1 is a -2. -2 plus 2 is 0. So we do have one solution, x equals 1. This is a remainder. This is a number. This is x. This is x squared. So what I have remaining is 2x squared plus 3x minus 2 equals 0. I need to still find 2 solutions. From here, I can factor it. I can do the method where you take the first term times the last term, or I could do the quadratic formula. I know we've been doing a lot of factoring, so for this example, let's go ahead and find the remaining 2 using the quadratic. A is the value in front of your squared term. B is the value in front of your single x. C is your constant at the end. To find out your discriminant, I calculate b squared minus 4ac. B is 3. 4 times a is 2, and c is -2. Well, 3 squared is 9. -4 times 2 is -8. -8 times a -2 is a positive 16. 9 plus 16 is 25. So when I go ahead and do the quadratic, x equals -b plus or minus the square root, b squared minus 4ac, we got 25 all over 2 times a. A is a 2, 2 times 2 is 4. Well, the square root of 25 is perfect. It's 5. So I have -3 plus or minus 5 over 4, and that's how I'm going to find my remaining 2 zeros. So remember, first, you add the numbers on the top. -3 plus 5 is 2. 2 over 4 is 1/2. And notice 1/2 was one of our options. -3 minus 5 is a -8. -8 divided by 4 is a -2. And again, -2 was one of our possibilities. So it's kind of awesome to see how it all ties together. Now what we want to do is go ahead and check and make sure that we did find the correct zeros. So I'll go back to Desmos because Desmos is amazing. 2x to the power of 3 plus x squared minus 5x plus 2. Okay, here's my graph. Remember, we can zoom in. I should have 3 zeros. We do. What we want to do is go ahead and check our solutions with where the graph crosses or touches the x-axis on Desmos. We should have a 1. Yep, 0.5, so 1/2, and -2. So we checked our solutions. Again, we're rock stars. Let's keep on going, guys. Number 3. P, if I look, I have 1, 2, 3, 4 terms. So if you go ahead and look and see if you would be able to factor that. If I grouped it, I could take out 2 x's. I would end up with 2x plus 3. I can't make that 2x plus 3. So I am going to go ahead and do the rational root theorem. P is a 3. Q is a 2. Factors of 3, plus or minus 1 and plus or minus 3. Factors of 2, plus or minus 1 and plus or minus 2. So in order to find my possible solutions, I need to take all of the terms on the top over the first value on the bottom, then all of the terms on the top over the second value on the bottom. 1 over 1 is 1, so plus or minus 1. 3 over 1 is 3, so plus or minus 3. Got it. 1 over 2 is 1/2, so plus or minus 1/2. 3 over 2 is 3/2. So here are my possible solutions. I need to find a total of 3. Let's go ahead and do some dividing. 3x's, 2x's, 1x, no x's. So 3, 2, 1, 0. I will not have to add in any zeros. It's already in the correct order. I have 2, 3, -8, and 3. I always like to start off with those 1s. And today, you guys, we've been pretty darn lucky. Let's bring down the 2. 2 times 1 is 2. 2 plus 3 is 5. 5 times 1 is 5. 5 plus a -8 is -3. -3 times 1 is -3. -3 plus 3 is 0. So guess what? We did it again. So x equals 1 is a solution. Awesome. Okay, this is a remainder, this is a number, this is x squared. So what I have remaining is 2x squared plus 5x minus 3 equals 0. I need to use this to find 2 more zeros. Now the last example, we did the quadratic. So this one I do want to factor. Let's go ahead and if I'm factoring with 3 terms, it's our multiply add method. Because I have a coefficient in front of x squared, I need to take the coefficient, the leading coefficient in this case, times my constant. +2 times -3 is -6. The same 2 numbers need to add to the middle, which is a 5. Well, that would be +6 and -1. +6 times -1 is -6. +6 minus 1 is 5. Because of this value in front of my squared term, these 2 values replace the middle. The middle term contains an x. So when I go ahead and fill those in, I need to make sure that I give them that variable. Remember, your first term will always stay. Your last term will always stay. The middle becomes the 2 values that worked when we were looking at our multiply add process. Now I have 4 terms, so I will use the grouping method. If I look at the first 2 terms, I can take out a 2x. That would leave me with x plus 3. I need this to match this. Well, the x matches and the 3 matches. What does not match is the signs. So I need to take out a -1. So that would be x plus 3. What I have here is 2x minus 1. Because remember, whatever you divide out, that is one group. What you have in common, what we got to match, that's another group. Now what we have to do is take each factor separately and set it equal to 0. So 2x minus 1 equals 0, and x plus 3 equals 0. Now to solve for x, here I add 1 and divide by 2. If I add 1, it would become positive, so I'd have a positive 1/2. Here I'd minus 3, so x would equal a negative 3. I have 1, 2, 3 solutions. That's how many I need because that's what the degree is. Now I'm going to go ahead and check this on Desmos. If I have 2x to the power of 3 plus 3x squared minus 8x plus 3. I do see that I have 3 solutions. Again, we can go ahead and zoom in. What we want to do is tap on those solutions and check our x values. We should have a solution of negative 3. Guess what? We do. We should have a solution of 1/2. We do. We should have a solution of 1, and we do. Okay, so looking at the time, I know that we are already at 20 minutes. I do have a couple additional examples. I will go ahead and write those out and post them on Google Classroom if you have additional examples. If you're feeling pretty good, there is a suggested assignment. Okay, I did not pick very many. What I did is I picked the ones that I felt were really challenging. Like if you could get 57, 58, and 59, if you could get those 3, you are totally good to go for the section. You are a rock star. If you have any issues as you're going through those, please let me know. Again, with these 2, I will go ahead and fill out, go ahead and show the work and go through the process, and I'll take a picture of it and put it in Google Classroom. So if you feel like you need more practice, you can go ahead and try those 2, and then you can go and compare your solutions with mine. I hope you had a great time today. I'll talk to you soon.